Hey, welcome to the Monday Morning Data Chat. Today we have Ben Rogojan, the Seattle data guy. By popular request, we've been getting a lot of inquiries for data engineering career advice. So we figured who better to have on than the Seattle data guy himself, who posts a lot of content about career advice in data engineering. So yeah, welcome, man. Good to see you.
Hey, good to see you guys again. It's been
Yeah,
a little bit, but I'm excited to kind of jump back on the show. Hopefully everyone's well.
Yeah, what you been up to lately?
Everything. No, everything from working to creating, like you said, creating tons of content. I think that's definitely been a lot of fun. Trying to figure out different ways to make content more both entertaining and engaging, and also make sure you're still giving people content. So I think a lot of stuff in that whole realm. Like again, like I said earlier, I kind of set up a background to be more YouTube-esque. I don't normal, otherwise it would just be normally a white background back here.
That's awesome. It looks good.
Yeah.
Those like sound tiles.
Yeah, those are just some sound tiles, and those I thought the hexagonal thing looked great, so I was like, okay, we'll go with that, and thank you, Amazon.
Do they make a difference in your sound?
I don't think they really make a difference in my sound. Like I think I'd have to like buy like another.
That's what I figured.
Like another 2 or 3 sets to actually make a bit difference there. I think it would probably make a bigger difference if I got like a couch in here, something like that, like a big piece of furniture. So
yeah, awesome. Well, cool. On the notion of career advice, I suppose, why don't we talk about how we all got into data engineering real quick? I think that might give some context, kind of setting up the discussion. Ben, how did you get into data engineering?
I think it's, I think it's interesting because like data science, obviously, I think was very popular by the time I was getting out of college. So I think that was where a lot more of my focus was. I was like, oh, what is data science? Let's like kind of dig into that. But the first job I was working at, like, it was more of like an analyst style role. And I remember I had been taking like a databasing course in college. And then I was like working on a database at the job that I was interning at. But like the whole time I'm like staring at it, you're seeing fact tables, you're seeing dimension tables, but your brain, because you've never heard of a data warehouse, your brain is just like, okay, it's just a database, right? Like with some interesting naming conventions. I think it took like 3 to 6 months for me to figure out that it's a totally different paradigm and concept and, totally different usage. So yeah, that's like kind of where like data engineering started. Like I had no idea that I was even staring at something that like, data modelers and data architects kind of developed over time that kind of, leads into eventually some data engineering work. I also started like working with SSIS and not really knowing that that's also something that's kind of utilized in this whole kind of path to ETL and things of that nature. So yeah, it was kind of like on accident, right? Like you're just using these tools because that's what you're told to use, but you don't really know why. I think that's like the big gap that a lot of people have. It's like, I'm just told to use these tools. I don't realize it's part of a bigger kind of conceptual idea. In fact, I think someone I interviewed recently talked about that, how there's not a lot of concept or conceptual stuff around, like, what is a data warehouse? What is a pipeline on YouTube? Like a straight course that can just help people kind of put this stuff into that framework, right? Because yeah, you have these tools, but if you're not putting it in that framework, it's kind of like harder to figure out why you're doing what you're doing. So then I started digging into that eventually, like, okay, what is data warehousing? What is ETLs? Slowly changes dimensions, all these different concepts that are, part of kind of data engineering or data modeling and all of those different components along the way. And then I just started applying for jobs that were kind of in the data engineering-esque role. And I think I just started looking up like jobs that required SQL and Python. And, that was kind of one of those things that generally fits very well there. And eventually got a data engineering job at a startup and started doing that work there. And then just continued to try to, improve on those skills and eventually interviewed at a FANG and got a job there. So yeah, it was kind of an accidental whole process. Like I think initially it was like data science that brings you into the fold, but then, eventually you figure out you like building stuff. So you're like, well, I'd rather build like some architecture, some components, versus just doing pure analytics and data science. So you start going that route a little more. So that's kind of how I got into it.
That's fascinating. What about you, Dr. Housley?
So he's making fun of the fact, I think, that I came from academia. So I used to, I got my PhD in math from the University of Utah, and I taught for, what was it, about 4 years or so after that. So I had a couple of teaching jobs. And then one of my friends who we were co-writing a paper at the time, which still hasn't come out because we now have these tech careers and have no time for writing papers, but he took a data science job, and then he kind of recruited me like, hey, why don't you come join, become a data scientist? I'm like, well, I don't really know anything about data science. He's like, read all this stuff and then come and you'll figure it out. And so I got this job and started working on data problems. And pretty quickly we had Teradata and Hadoop, and I kind of started to understand some big picture things about the data landscape. So kind of like you were saying, Ben, what is data warehousing? So you figure out pretty quickly you have this very curated data. It's like a nice shape, but then you try to dig into the web event data and it just doesn't really work because it's too curated, right? And so you quickly discover that you need something maybe a little bit closer to a data lake to do data science, or something a bit more raw, and you have to be able to get deeper into the data. And then on the Hadoop side, we just had such performance issues and there was nowhere to automate anything. And so even if you built a good model on your laptop, it was very hard to deploy in a way that would impact the business. And so gradually I kind of drifted into, digging into ETL scripts, digging into what Hadoop was doing, trying to figure out how to automate things, and actually, make use of all this data we had that we'd invested so much money in. And then it was also around that time that we, as a company, got real serious about investigating cloud. And so I was involved in a couple of different cloud POCs, one on AWS and one on GCP. And then seeing those data tools was kind of a revelation, right? Frankly, Teradata, everyone talks crap about Teradata. It's pretty amazing for what it does. It's a bit old. But the fact that you could just go into AWS and spin up Redshift and you could scale it and throw your data into it, or you could just run queries in BigQuery, that was kind of awesome. And so I gradually discovered that maybe data engineering was what I wanted to be doing, because there are actually a lot of interesting problems to solve, infrastructure to build, and frankly, you can have a big impact on the success of your data projects if you work closely with data scientists on data engineering. That was my journey. How about you, Joe?
Similar-ish. I think it was more out of necessity than anything. I've been working in data for a long time in some way or another, right? But I would say, when I started working at a startup, we're doing auto ML at the time. What I realized very quickly was, this is back in the very early 2010s. So the whole idea is just give it, provide a data set, get machine learning predictions. So sounds easy. Unfortunately, I think at the time, especially, there was nothing in the way of machine learning frameworks. There's nothing in the way of, there was no such thing as ML ops or ML engineering. Realized that a lot of the complexity around, at least what we were trying to do, was more of an engineering problem at the time. Maybe it wasn't really an algorithms problem per se. And so that got me interested in just the general notion of engineering as it applies to data, right? I think this is before data engineering was cool thing. And so, just dived into that, like I said, this is born out of necessity because it was impossible to do our jobs. You had to start building the systems to do this. So, at the time, my title was software engineer because like I said, data engineer wasn't the thing. So, and then started noticing, the maturity of the landscape as well. Cloud, and I saw Redshift come out in 2012. It's that's cool. It's cheap for one. And, then I think just, kind of been along with the ride from the beginning, really. So that's how I got into it. It was more out of necessity. I wouldn't say it was because it was the cool thing to do. It was just again, you needed to do this to do your job. And there was just back then, though, there was no frameworks, no best practices, really. I mean, you kind of had the big data tools, but I think at the time too, what I noticed is there's a lot of, I think kind of me too is hopping on the bandwagon of doing big data tools, but maybe you didn't necessarily have the problem, but it's spinning up Hadoop, whether or not it made any sense at all, or using Spark, because that was what all the cool kids were doing. So I think as much as, understanding the landscape, also figuring out what tools were going to be the most appropriate for what situations. And so, and that kind of led me to today and chatting with you guys about data engineering. So it's always interesting.
And writing a book. All kinds of crazy.
But so I think that it's interesting too, the career advice around data engineering, I'd say it tends to change a lot, really. So the advice I would probably give somebody 5 years ago, 6 years ago is not the advice I would give today. But speaking of which, we have a question actually from Drew Ibsen. What's up? He asks, I just accepted a role as a data engineer and am graduating next month. I notice a lot of overlap between software engineering and data engineering. Is that accurate? And do you work on equal parts data modeling and software engineering? What do you guys think?
Yeah, I mean, I think obviously it's always the answer is always it somewhat depends, because it's going to depend on the tooling that you're using, the data stack that you're using. I think, I like to think of it like, when you say software engineering, I often kind of like when people bring that into like the data engineering versus software engineering, I think you're thinking like code and then developing like maybe systems and things of that nature. I think there's like, we use a lot of the tools, right? Like we might use some things like programming or object-oriented programming or things of that nature, but like it's applied towards data problems. Like, again, maybe if it's applied towards ETL, maybe you're building your own data infrastructure. Maybe you're, building some components that are like software-esque, but it's towards trying to apply it towards a very specific problem. So it's just specified, I think, in a different direction. There's obviously the data modeling component, but like, how do you get that data there? That's the part that might have some like software engineering-esque like terms, but it might have none, because you might be using like a ton of like low-code solutions that then like you focus more on maybe some of the best practices that you use in data in like software engineering, like version control and things of that nature, but not maybe no code, because or very little code other than like some SQL. So that also just depends on the data stack that company is using. And yeah, it's more of just like, again, programming, which is a piece that we take from software engineering, is one of the many tools we just use to kind of move data. At least that's what I found.
Yeah, and I tend to agree with Ben on this one. I think one of the differences between being a modern software engineer and being a data engineer is that this is a generalization because there are many types of software engineers, but if you're a software engineer who works on microservices, then you're used to thinking of data just coming in as one event at a time. And that's how you process it. It's event driven. You have something come in, you process it, maybe make a call to another microservice, something like this. And typically what software engineers struggle with at first in making the transition to data engineering, they can learn it. They generally, capable software engineer can definitely learn data engineering. But it's this idea of thinking of data as massive sets. And so now you need to think about, I'm not thinking about an event. I'm thinking about 1 million rows or 1 billion rows. How do I think of that set of data? How do I think about things like joins? How do I think about duplication, unique keys? Like, these are elements of data intuition that you just kind of have to acquire as a software engineer. And so I think coming into this job, ideally, you'll get that data intuition pretty quickly. And like Ben said, then software engineering will become one of the tools you have available to solve data problems from that paradigm of understanding data at scale. So.
Yeah, these are good points. And I think there's also a continued level, an increase of abstraction and simplicity with tools right now. So whereas back in the day, you would have to write a lot of this tooling, now it's either open source or managed for the most part, right? SaaS especially. There's no shortage of companies out there that'll give you basically any type of solution you want right now, or open source projects. Usually both, actually, right? Start out with open source and become a company after these days. But what we also see, though, I would say, like software engineering, though, the principles still apply, right? So you need to know how to write good code, right? What is good code? It's code that's readable, performs well. You need to know how to debug and test software, right? And so I don't think like the software engineering goes away with abstraction. What I do see is that you're going to write more custom code for areas that are a competitive advantage to you, right? So anything that's not a competitive advantage, like why on earth would you hand code that if it's already been written and done 1 million times? Like, that's pretty dumb in my opinion and a waste of your time. But that also frees you up. The simplicity and abstraction with data engineering tooling allows you to now focus on areas of extreme competitive advantage, which is where you should be focusing your attention anyway. And so by contrast, writing connectors that move data from a MySQL database into BigQuery or Snowflake, to me, that is an utter waste of time. You shouldn't do that. There's a ton of solutions that do that for you. What you should be focusing on is what's going to move the needle for your company, or your organization, and focus all your attention there. So good question.
Yeah, and I'll loop back to something Ben was talking about before the show, and that is, in this domain where you're presenting about data on YouTube or on LinkedIn, you end up spending a lot of time researching solutions because people ask you questions. You're like, that's a good question. I'm an expert on BigQuery. I'm not an expert on Redshift, so I need to go research that. And that turns out to be a big part of the data engineering job too. To Joe's point, a lot of it is like finding the best solution to solve your problem without reinventing the wheel, right? So like going out and saying, well, here's a problem I have. Can I solve this with something simple? And then you do a lot of research, you go to meetups, you talk to people. If you can't find a solution, then you do something custom. But don't like start out doing something custom. Become a researcher instead.
Yeah, for sure. So, Alberto, what's up, Alberto? He has always such good questions. He asked, what can we expect from the tech stacks and tool landscape from the data engineering view for 2022 and 2023? It's a good question.
Yeah.
What do you guys think?
I'm hoping a little bit of consolidation personally. Like I'm really hoping we can start consolidating some of these solutions, whether they're buying each other out, and we can start like defining what is good tools to use for the next maybe 3 to 5 years. Obviously I think Fivetran got that $565 million funding round, which I think that's part of it, right? I think part of it's them realizing they need to start, actually taking a serious chunk of certain people's businesses to either eventually start consolidating different solutions and putting them together. So that's one thing. Because right now, if you're looking at the whole landscape, there are so many solutions, and there's a new data ingestion tool that comes out every other day.
Yeah.
So I think that's something that I'm hoping for. Otherwise, we're going to keep going into this constant adding of new tools, which is great, right? Like we're trying to polish something up, but I think now at this point, I'm hoping we can focus in and start picking things. I'm curious also, like with it's like kind of going to the future, if we'll start seeing things like Redshift try to maybe, I don't know, try to feel less clunky. I think that's always something that I'm curious to see. Like, Snowflake's kind of done a good job at like paving the way of just being like, well, let's just make a database work like a database so that people aren't sitting here trying to do all these workarounds. I'm curious to see if AWS is going to kind of try to take that on. But yeah, so I think that's kind of like an interesting, hopeful consolidation of all these solutions. Because again, I think in the last 2 years, people realized, again, after Snowflake's giant IPO, that data is a huge space that can make tons and tons of money. I mean, they've always known it, but like, I just feel like tons more funding came in. So I'm hoping like after that, maybe in 2022, some things can start maybe just funneling down, and we can start just having a little bit of a clearer picture on what companies are actually relying on. And, it's not just all marketing and sales kind of telling us what companies are using. So, yeah.
Yeah, that's an interesting comment about Redshift, because certainly you see Amazon trying to grab features from BigQuery and Snowflake, like features they like separating compute and storage, but it all feels a bit tacked on right now. It's like they're always, I got to go turn on RA3 nodes. I've got to go turn on this feature. And so, yeah, it would be really nice if it were just a fully managed solution where you never had to think about any of that stuff, and it was just completely seamless. So maybe that'll happen in the future. Yeah. And the consolidation comment is an interesting one. Yeah, because I think, and Joe, I'll be curious to hear your comments, but I think one of the things we've seen is that a lot of the focus is on data management. And so that's things like, automated data ingestion tools, metadata management, data quality monitoring, and such. And all of these companies have kind of cross like good and perverse incentives. So the good incentive is that they all want to interoperate with everyone else, because that's what's going to make their tool popular. If you're Fivetran, you want to interoperate with as many APIs as possible. But they don't want to be such a standard that they can get replaced. They don't want to be just compliant with some industry standard where someone can drop in something else. And so you do have this problem of like just too many cooks in the kitchen, too many different solutions that play nice together, but not quite, where there's always friction between the different solutions. So yeah, I kind of view it the same way. Hopefully a lot of consolidation.
It'll happen at some point. It's interesting. I was talking with Matt Turk about this, actually, about his data landscape slide a couple of weeks ago. And it's not a question of if, but when consolidation does happen, right? But as you point out, Matt, too, it's consolidation in certain areas, I would say. In other areas where like data management, I would say that's still, it's kind of like data management 2.0 or 3.0, where you're starting to, Scott Taylor kind of quipped like data quality, it's always been there. Master data, it's always been there. But I think what you're seeing now is the accessibility of these practices and tools are sort of being rediscovered and available to smaller companies and organizations. Whereas before, like if you wanted to buy something, off the shelf for say MDM, it's going to cost you a lot of money, right? And so, or data quality, for example, data cataloging and so forth. So the cost is just dropping on a lot of these things, or it's free in some cases, right? Because it's open source. And so I think that's going to happen as well. The modern data stack, I made a quip on a podcast the other day. They'll be coming out like it's so old it doesn't feel modern anymore. I think also what you're going to start seeing is the popularity of more streaming oriented solutions, and low latency query engines, stuff like Firebolt, for example. Imply is doing a hell of a job. with latest tweaks in their engine. And I think that's going to be the next area too. And that's why the modern data stack doesn't feel that modern anymore, because I think of the rise of a lot of streaming oriented, low latency type solutions that just kind of fly in the face of a batch oriented data stack. Which, modern data stack's great; it does the job for today, but skate to where the puck is going, not where it is. And so I think that's also where things are going. Good question. What else would we expect for 2022 and 2023? Privacy and regulations, I think, are going to be a really big one too. The EU's AI initiative, if it ever goes anywhere, but it's more kind of I've seen rumblings even from states like Colorado where they're going to have their own privacy laws too. So it's this will be just fascinating to watch, and it's going to have a direct impact on the ability to use tools and execute on data engineering initiatives.
Yeah.
Go ahead.
Go ahead. Oh, I was gonna say it's not just that. It's going to drastically make our jobs harder. Not just because because if there's not a consistent standard, one, it just ensures more job security, but that lack of standards is just going to make everyone's job can you imagine having to implement a data privacy standard for every different state and then every different country?
Yes.
It's like that would be insane. It's going to be like you're going to have to someone's going to have to create basically a service that's going to do it, right? Like, yeah, you got it.
No, I say it's a startup idea.
Yeah. So sorry. Well, no, it's like cause I think
no, it's a good one though.
For taxes, right? Like I don't know what.
Sales tax is a big one.
Sales tax
this dwarfs sales tax.
Yeah. Oh yeah, it's going to be far more complicated. Like
gray areas. Sales tax is just like multiplied by a percentage in whatever locality you happen to be in. This is like, how do you interpret this law? Yeah. It's crazy. So I think things are just getting started. Really, like consolidation is certainly going to happen with tools. As you point out, though, I think what's going to change is just everything else is going to keep getting more complex. I don't think the role of a data engineer is not going to become any easier.
No.
I think it's just going to get cooler in some ways, though, because now you're focused on higher level stuff like lifecycle management versus lower level tool management, which maintenance is fun for usually nobody. So
yeah. No,
there's a certain identity that comes with maintenance, though. I think people just they feel valuable if they're in there, restarting a Zookeeper server or something like that.
Well, it's the old saying, right? Like legacy is like a kind of a condescending way of describing something that makes money.
Yep, it's true.
So
yeah. I'm sure Google is still making plenty of money off their legacy software called search. So yeah, it's like I think it'll be interesting kind of seeing as we go forward, just like tooling, like you said, it's like data is just growing at such a pace that, like you said, you brought earlier, streaming, like that's a component that we're trying to bring in, I think, more and more, which currently with our current landscape of tools, like would be impossible, to like manage properly. Just like all of these different solutions that are just going to hopefully make our jobs easier, because we like small companies these days that are like $100 or $50 million in size or have like 40 data sources. You can't, what are you gonna do? Hire 2 data engineers each for $150K, paying $300K for them both. And then on top of that, whatever tooling you're using. So you're almost spending $1 million on data, which is a giant portion of your company. Again, not even talking about your data analysts and data scientists. So, it's just impossible at this point to maintain a system, without some sort of tooling to kind of try to reduce it,
Actually, to follow up on that too, there's a question here. As a sole data engineer in a small organization, what are your recommendations on the areas to grow into as a company grows and roles start to specialize? It's a relevant question.
Yeah. Yeah. And I just, since I was kind of starting in that area, like, I think you mentioned it earlier. I think both of you, like, picking the right tools is definitely like having that discernment of like where you can spend time and where you can't is important, and what's important to your company, right? Like first if you're the only data engineer, you can kind of take that role of being like, okay, I'm the person that needs to also start making like executive decisions here in terms of like, I need to talk to management, see like, what do you want from your data, right? Like, what are your major goals? So that way you can kind of start, picking the right tools that can help them get to those goals over the next 2 to 5 years, as well as save you time, because, again, you do not have time. I've been watching a lot of, I saw, I think like 2 or 3 videos where like people from like either ex Facebook people or people that work at Facebook, both like in the last 2 weeks referenced like ruthlessly prioritizing, which is like a weird terminology. I don't know if other companies use it, but like people at Facebook use it all the time. And it's something that I thought I was like, oh, I'm great at prioritizing until like earlier this year, where I was like, no, I'm just really good at outworking my problems until I had too many problems that like I didn't want to do the work. So I think that's something that like, you got to realize you're eventually going to run out of wanting to work, and you shouldn't be working more than a certain amount of time anyways. So figuring out how you can like pick the right tools to make sure you're doing the right work and prioritizing the right things, I think is an important skill. And part of that is like learning to talk to management to figure out what they think is important, and then driving those initiatives and making sure you're communicating with them and being like, okay, I can do X and Y. We can't do Z for now. Is that okay? And figuring out, how to drive those things forward.
Interesting. Yeah. And I mean, I like that term, ruthlessly prioritizing. Maybe I've heard it before, but it's really resonating today. And it's funny, like tool choices could make a big difference if you're a solo data engineer. Even like you were saying, Ben, the difference between Redshift or BigQuery and Snowflake, where those solutions are way, way more fully managed for you, could make a big difference in terms of your ability to get work done. So like, prioritize just super, super simple solutions at this stage. And then when you actually get more people, you can cross that bridge when you come to it.
And automate as much as possible.
And automate, yes.
Right? Yeah. Again, there's no glory. I think everyone, because you have the word engineer in your title, you want to engineer things. Like that's just kind of what's implied. But I would say, ruthlessly prioritize focusing on areas that, again, are going to move the needle as a competitive advantage for what your company's trying to do, especially at an early stage startup, right? You don't have a lot of time. Time is your biggest enemy, right? Or your biggest asset, depending on how you look at it. But if you're spending all your time, fighting low-level fires and stuff, you're not going to get as far as you can by just, ruthlessly prioritizing what you need to focus on, one or two big things, and automating the rest. Yeah. So, and instill that as a culture too. As you grow your team, I would say engineers want to engineer again, right? And so just reinforce the notion that things need to be automated, add value, those types of workflows and thought processes. So.
And there's going to be opportunity to engineer things. Don't worry. Like there's always those like long tail things that aren't covered yet or whatever. Like you'll have opportunities to get to it when you need to. But like you said, for the most part, it's like all you're doing when you're engineering things is creating maintenance in the future that you might not have time for. Like I always like to say, it's like every data pipeline you create, especially if it's like code based, just creates like 2 to 4 future tasks. The pipeline fails. You have to add new columns. You have to do all of these things. And on top of that, it's like running. It's just extra maintenance. You're already gonna have to do that stuff. So, you don't want to be stuck just constantly maintaining systems. You want to eventually start trying to move away from that. Or, sometimes always in maintenance, but not, 60% of your day is on maintenance. Then you're going to have a hard time building any new value.
That's a good question. Peter asks, there are new data roles that have been kind of birthed in the last decade. Analytics engineer is one of them. Can you shed more light on this new data role and how does it help companies manage their modern data stacks? So it's about analytics engineering and modern data stack. So what do y'all think?
I think part of it is this is an evolution of the existing role of ETL developer, maybe adopting some more fluid modern software development practices, things like version control. I think for many ETL teams, say 20 years ago, that wasn't really happening. And I think they also cross over a bit more into modern data engineering practices. So analytics engineers might work on things like effectively what we used to call ETL pipelines, but maybe running in a data lake environment or something like this, rather than just on a Teradata system on-prem, for example. I don't know. What are your thoughts on this, Ben?
Yeah, no, I think what you're kind of seeing is like, and I did this in a video of like data engineer versus software engineer, where I talked about like data engineers, like at least for the longest time, have kind of played this like either it's some companies that are more of this like analytical component where they play, like you've talked about, like ETL developer, kind of do a lot of SQL work, things of that nature, maybe some coding, or on the other side, they're like very heavy in programming, right? Like writing like MapReduce scripts and doing tons in Spark and things of that nature and coding a ton. And so I think maybe we're just kind of seeing more of a bifurcation of that role where it's like a little clearer, where it's like, okay, these people in theory are more, analytical. They're doing more stuff, like you said, like in dbt or some other version controlling system and doing things a lot heavier in SQL. And then on the other side, the data engineers are really just focused on trying to parse events and do a lot more heavy coding. I think that's kind of the theory. Obviously, I think a component of it is also, the more dbt can create this into a role, the more people will be like, oh, what do analytics engineers do? Oh, they use DBT. Okay, great, let's use them. Obviously, there's that component, but I think there's reasoning behind that, right? Like it's good things that we're trying to pick up. I did this other thing in my recent video where I was talking about, like, when I first started doing data engineering work and SQL work, I would not necessarily always save my SQL, or if I did, it would be like finance query 0.1 or something, and no real version. Like you just got your first job, you're not really thinking about how to properly, SQL. You're like, oh, okay, this will be, no one's going to ask me for this again, and then you get a question about it again, and it needs a modification. So you just make a modification, save over it, and then someone's like, oh, can I get the original query? And you're like, okay, I don't have that. Let me go rewrite it. So I think things like that, like just creating that process around this whole process of like analytics engineering in itself is good, because I think when you get out of school, you don't really, like, there's no real process in how you do analytics. You just, like, I guess I write queries and do some, Excel notebooks or Jupyter notebooks. And so, yeah, I think in that regard, I think it's good. I think it's something that will hopefully help us at least develop that kind of like best practices in that kind of analytics pipeline. And that's kind of where I see that whole kind of concept going.
For sure. Yeah. I think analytics engineering, it basically took a lot of the best practices from software engineering and applied it to data, right? But as Matt points out, it was really no difference in practice versus what BI or ETL developers have been doing for like the last 20, 30 years either. So, but, it's more kind of X as code, I think, is a big difference. So applying, concepts of data, practice of data ops, for example, right? Data management and so forth, but with a modern twist, right? So it's kind of the notion that also like data is about, 5-10 years behind where software is, just in terms of like best practices. But I think that's sort of the notion of where analytics engineering is going to be adding more value in the stack is, continuous deployment, automation and that kind of stuff. That was really missing, I would say, from kind of first and second generation data stacks, where it was very monolithic. That kind of thing. So, but again, it's nothing that's that new. I kind of don't like the term analytics engineering. Actually, I think it's a bit. I understand why it exists, but I think it was a bit unnecessary of a term.
Yeah, I mean, I think, like I kind of referenced earlier, like certain, like even the modern data stack, analytics engineer has kind of all been very much around marketing. I think maybe someone said it first and everyone kind of jumped on it. It's like, oh, if we include our product in here, people will, when they Google analytics engineer or what is modern data stack, they're going to find us too. Which, again, like from a person that also does content marketing, I can totally like understand. Yeah. As well as like, trying to create best practices, you need to have some defined terms of some kind.
Yeah, I think it first appeared. What was it? Michael Kaminsky, I think, was the guy from Locally Optimistic who came up with the. At least I think the first citation of that was from Michael for analytics engineer, and the modern data stack I think came out through the work of like the folks at DBT and Fivetran and so forth. But again, I think it's good. And it's good to kind of, it establishes sort of an epoch as well in terms of where we are in a progression of data tools and practices. Like I said, I was joking the other day on a podcast that, again, the modern data stack, it's not even that modern anymore. So it's just a data stack, right? I think the next wave is actually going to be talking about Mike Nash's question here.
Yeah, nice.
Sort of. With the rise of ML, using ML and AI for further insights, what is a good level of understanding for spinning up an average ML AI project within data engineering? This is what I'm alluding to. I think this ML and AI and streaming are two of the areas where I think there's going to be a lot more overlap with data engineering over the next few years. But I'd like to get you guys' take on his question here. What's a good level of understanding for a data engineer to spin up a ML and AI project?
That's always going to be, I think, interesting, because you're always going to have the two sides, or at least two sides on ML and AI, right? The people who believe you need to be the purest math, guru to do ML and AI, and people are going to cite, I think, Zillow's current situation on that. I think I've seen a lot of posts on that where they're like, oh, well, they were using like Profit or something, so they should have like developed their own whole system to kind of create this model rather than relying on someone's external system. Or, like you could say like, okay, but can we do good enough ML, and then hand it eventually, like, be like, okay, this kind of proved our point. Now can we hand this over to someone on the research side? I mean, my perspective has always been like we tend to do more implementation of ML and AI and do a little less in terms of like maybe the research itself, which means sometimes we just have to do a lot of work in optimizing things. Like sometimes a data scientist or an ML person will just kind of give you a Jupyter notebook, and then you're like, okay, well, this isn't going to run this way, so we got to like rethink this. Maybe create a little more observability as we're going through, and not just everything kind of hidden and abstracted away in data frames. I think at least having like a general idea of what they're trying to do is good. Like how you want to store that data, how you want to kind of be able to re-grab that data. Like what are they going to use it for? Do they need that? Do they need like some sort of output that's pulled by an API? Do they need, where's it going back to? I think it's always nice to know at least some of the algorithms and what they do. I think it's always worth knowing, at least from a high level. You don't have to actually understand the pure math, but that way, at least when someone hands it to you, you're like, okay, I know what you're doing from a data perspective. I can kind of work with that. But yeah, I'm still curious to kind of see like how much overlap do we want to put into data engineering, and like how much is it going to be ML engineering? Is there too much crossover there? So yeah, I'm curious on Matt, since you are a little more mathy, kind of your perspective on that.
Pure math too.
Yeah,
pure math. Yeah. And the thing about pure math, excuse me, is that no one knows it all. Like it's so vast, and the same is true of data science, right? Like I think if you actually talk to data scientists, it turns out that even the really good ones are good at like one tiny set of skills. And then for the rest of the stuff, they need to talk to other people or go read Medium articles or something like this. So I kind of like, there's a lot of pretentiousness around data science where people on LinkedIn will post about how you should never use any kind of auto ML tool, or you should never use Profit because that means you don't really know what you're doing. And like, I know for a fact, I know you, and I know that you don't know what you're doing in these domains. I know that for sure, just based on your background and the conversations we've had. No one knows it all. Yeah. But I think there are a couple of really important things here. So first of all, if you are going to use any kind of auto ML tool as a data engineer, you at least need to be good enough to do model evaluation and testing. In other words, and that goes to what you were saying, Ben, observability. So model observability. How is my model performing? And then I think the other lesson from Zillow, which really good that you brought that up. That's interesting. I mean, it's not just that they were using Profit. It's that, as Nicholas Nassim Taleb might tell us, they failed to evaluate their worst case scenario. Like, is there a potential here to lose a lot of money? Apparently, no one was really asking that question. And
well, you're forecasting in a very dynamic housing environment for one, right? Yeah. It's like all forecasting models blow up in this type of scenario.
Right. Well, not only that, but think of long-term capital management, which we don't think of as a data science disaster, but it kind of was. I mean, you had these very, mathy people who came up with Black-Scholes and thought they had solved the market. And it turned out that when first of all, dynamic situation, like you said, Joe, and then when lots of people started doing the same thing, it completely broke the model.
Yeah, Black-Scholes assumes like normal distributions in your data, but nothing, things in the real world aren't Gaussian, especially when you had like financial crises, the model didn't account for that. The LCTM back in, what was it, 97 or 98, and that model blew up. But this happens time and time again, I would say. And let me just go about a tangent for what you're saying, but like understanding, I would say, like when to use ML and AI and when not to use it, I think is also what you're sort of hitting at, right? Zillow messed up, I would say, because your model works. Forecasting works in a pretty static environment. Profit will work then. Profit doesn't work when you have 30% year-over-year increases in housing prices, in dynamic environments, especially, given everything else going on in a pandemic. It's too dynamic for that type of a model to account for. I know how profit works under the hood.
Right.
It won't work in this environment, period.
Right.
So there's that. And I would say for a data engineer, like to bring it back to Mike's question, I think what you need to know is what techniques would be good to use, or at least understand like what would be an expected outcome. Because it's not your job really to know like how a model needs to perform at a granular level. Ideally, it's a data scientist job. Otherwise, you're also a data scientist. Congratulations. And now you're a unicorn, so you should be rich. But I think understanding how to deploy these models and when to retrain them, I think is good. But again, that falls into ML engineering too, right? But this is sort of an interesting thing too, where I think ML engineering and data engineering and software engineering, the lines are going to be blurred over the next few years. Because really, when you look under the hood at what you're doing, what are you doing? It's observing stuff, you're building pipelines, and there's some subtle differences. Some people push back on this, but what I think more to my point is you're going to see a morphing of titles going on. Whereas things aren't so neatly packaged as I think we conveniently want them to be in data. So. Yeah, good question. But the level of understanding for ML and AI, I would say at least know how machine learning works, like classification, regression, forecasting, that kind of stuff. But I don't know. that changes a lot too. So
yeah. And that's a bigger management problem. And this is not just a data engineering and data science problem. Again, understand what risks you're taking. Like this is just an ill-advised project for Zillow to get into where you're dumping huge amounts of money into the housing market. You could potentially lose your shirt on it.
well, they're trying to make a market too. That was the other thing of it, right? Where they had such clout where they could make local markets, and it worked until it didn't.
Yeah.
Right.
Exactly.
Now you have to lay off 25% of your company as a result. But you have other iBuyers that are doing just fine.
Yeah, well, that's because they foresaw it, right? Like I think that's what everyone said. It's like they were like, oh yeah, we're chilling out right now. Like probably because they're like, yeah, we have no way of being able to predict this, right? And I think Zillow, like 4 weeks before they laid off people, like had that conversation. They're like, that's what their messaging was like. Oh, we're slowing down because it's just a little too hard to see, and we have no idea what's going forward. And it's like, but that was like months after these other iBuyers had already also been like, yeah, we stopped forever ago because we needed to see what's going to happen. There's no way
variation in the forecasts.
Yeah.
So, and anyone who survived the last housing crash remembers that it's like riding a roller coaster with a blindfold on, right? No one knows where the peak is, and if you happen to miss that peak, if you buy in at the very top, you're in for.
I remember getting a job as a forecaster in 2008, in August of 2008. that next month, the economy imploded on itself, and so I'd been forecasting for a long time, and and all I knew was like, this ain't gonna work right now. So and that's a story for another day. But the whole point is like when things are gonna work and when it won't, right? And so Zillow is an interesting one. I'm sure there's probably a lot more to the story we haven't heard too. The other part of it, right? So
for sure. I mean,
back to a more innocent question. What's the place of Kimball data warehouse in the modern data warehousing methods? Do we still need to explicitly set up facts and dimensions?
I personally still like it for like more reporting, right? Like it's the way I was explaining it is like sometimes I think as data engineers, again, people who are very engineering focused don't understand that you're creating for analysts and data scientists and maybe like people and other people who just like who maybe don't even know SQL, who are just like Power Query users and kind of connect things, very like, using tools and low code solutions. And I think the facts and dimension concept works mentally. I think we understand it very well. It's very clear, right? Like when someone asks you to do some sort of basic reporting, it's usually like, oh, can you give me this by year, by product category, by whatever for sales? Like it's very, standard, and our brains can understand that. So I think oftentimes that's not just for like the engineering component, that's for the people component. It's like people understand this concept very well. So I think for like reporting, it makes sense. I think the thing that doesn't make sense, but you alluded to this earlier, Matt, where it's like web data and other things that are really dirty, then that stuff makes sense in that like data lake, or, as obviously data lake house is also a term coming out, but like at the very least a data lake, because it's like, okay, that stuff's harder to kind of model, or it's just got a ton of extra information, or maybe we just don't have time to model it. So we're going to put it into a data lake so that we can, use data scientists and machine learning engineers who maybe are more SQL heavy or code heavy, kind of access that data. So yeah, I think it's still going to have a place, just because, again, as people, we understand it. It's more about us and the people who are using our data that need it, not necessarily us as engineers who were like, oh, this is the most optimal way. Maybe it is the most optimal way, but it's definitely, I think, one of the more optimal people like understanding ways.
Yeah. And I think my opinion is that there's a book yet to be written that will kind of be the next generation of data modeling, where basically it doesn't throw out normalization. Because for years, the advice from Google was like, just denormalize everything. Well, what the hell does that even mean? I have no idea. It doesn't make any sense. But at the same time, rigidly applying Kimball and saying everything has to be normalized doesn't really make sense.
It's a bit of a cult or a religion, I think, too, right?
Yeah.
Then you have your data vault people, and I think it's, and then Inman and so forth. But the thing is, these techniques have been around for quite a while. Business logic needs to be modeled. Right. But I would say that, especially given, new paradigms in streaming and so forth, look back to, the Data Warehouse Toolkit written by Ralph Kimball, right? That book was written, if you read between the lines, it was written because, one, modeling is a great thing to do. But two, you had a lot of constraints based upon the technical requirements of the relational databases that you're using to house your data warehouse, right? Yeah. So that was a big thing that he hit up on the book. Is like, you have to do it this way because it needs to perform, given your technical constraints. You don't have that anymore. Yeah. And so I would say, do Kimball, do something that works. Yeah. I would say, but that doesn't throw out the notion of like modeling your business data, your business logic. But it doesn't also mean like ruthlessly just, ruthlessly prioritizing, some sort of a dogma either. I think, and as Matt says, there is a ton of opportunity right now for new methods and new thinking around data modeling. I think you're going to see it. My prediction also for 2022 and 2023, perhaps you start seeing new, dogmas being developed.
Yeah.
With modeling. So maybe one of us will write that next book.
Maybe so. Maybe this is a three-way collaboration. If the current books, are you writing a book as well, Ben? Or
I'm not currently.
Okay.
I at some point, like, it's funny because I keep looking at the amount of like written content I've put out, and now video content. I'm like, there's a book in there somewhere.
You basically have a book.
I know, it's like there's a book in there somewhere. I just need to like sit down and do it. I think it's interesting they bring up like the whole data modeling thing, because like I think that, like you said, Google and like a lot of people's like mentality there for a while was like, oh, just have giant tables, right? Like just denormalize, and it's like it just doesn't. I think it just doesn't work in the end a lot of times. Like, or if it does, because you end up having to change something. It's just too like rigid at the end, because then it's like, okay, well, I need to make like this small change, and it's like, okay, where if you have broken up tables, you can kind of, I think, more easily touch one table, make that change, and then improve your query or something like that. So I'd be curious to see kind of like what's the next idea. I think what you said, it's got to be like almost radically new, but like radically new and radically just better. And it's like, what is that? Because I think most of the other options these days is like, maybe it's new, but it's not necessarily better. It's either the same or just takes longer or something, where it's like, it's not a good enough trade-off to switch mentalities. Go ahead.
No, what are you saying?
Oh, I was just gonna say, I mean, like, I think that's why people jumped back on Snowflake as soon as that came out, because it was like, okay, we can run update statements. Okay, we can now go back to doing slowly changing dimensions normally and not have to go through this whole, crazy set of loop or jumps just to like try to add in a update time, or new effective date. It's like,
I mean, there's a notion of the Lindy Effect as well. You guys familiar with that?
I don't remember that one.
So the Lindy Effect basically says like, what is old will continue to be around. So like SQL and Bash and Unix, right? Like, so at a certain point, I think things have a longevity and they do stick around.
Yeah. And
so maybe, it could be argued that things like Kimball and Inman and Data Vault are so old, they're just going to continue being around too.
Yeah.
So, but I would say, it's streaming changes a lot of stuff. You're not really going to be doing Kimball, in a streaming platform like a Kappa architecture, for example. That'd be like sheer lunacy. Yeah. That said, maybe there's some way to, to do this that we aren't aware of yet, or maybe. So if anyone's doing this in the audience, or catches the recording, drop us a line and let us know. But I think the data modeling, especially in flight transformations, are going to be sort of the next wave.
Yeah.
So it already is with some companies and already has been, but kind of mainstream, that's going to be a different thing. So
yeah. And maybe we need a new set of tools as well. I mean, as we were talking to someone the other day about data modeling, and I made the argument, it's like, look, for a lot of things, arrays and nested data are very, very natural once you get used to them, right? Yeah. They're actually a better data structure than full normalization in certain areas. And they pointed out, but it's really hard to update arrays. Like, well, that's a good point. Maybe we just need better types of SQL.
But why do you need to update?
Yeah, that's a good question, right?
Right.
Yeah. And maybe that's where you look at your data modeling and you adjust it somewhat in terms of what goes in arrays and what becomes factor dimension, what's a separate table.
Yeah. So cool. Any other career advice? This wasn't really career advice. This is more just
I know. It's like
data engineering advice.
We talked about
I guess one question that I have is like how for the question that we always get, and I think one of the things that spawned this conversation is if you're new to the field, how do you get into data engineering?
Yeah, I think there's a few like obviously natural routes. Like I think the analyst to data engineer is usually kind of a natural flow. Like especially if you're maybe like someone who has some programming knowledge, and then maybe just you got an analyst job because that's the first job, because it's hard to get maybe a data engineering job or even a software engineering job like right out of college. So maybe you got an analyst role instead. You've been doing a ton of SQL. You've been working with data warehouses. Maybe even made an ETL or two, and now you just have to basically practice for interviews. Maybe work on making sure that you highlight those roles or those kind of projects that you did that were a little more data engineering heavy on your resume, and then trying to go interview. I think that's kind of the classic route.
Mhm.
I think I've been seeing a lot more junior data engineer positions or data engineering intern positions as well, especially at like the big FANG companies, because
Mm.
they're realizing that data engineering is an important role. They realize it's slightly different than software engineering, and that you need to have a different mentality when you go forward in working in that space. So yeah, I think I'm seeing a lot more intern roles as well. I think Facebook's been hiring a lot more data engineering interns. I'm sure I've seen like Google hiring data engineers, which is new in itself. So I'm sure they'll have interns, and that's interns always going to be the easiest route.
Build versus buy. Yeah.
Yeah. So
What do you think about certifications, Ben? What's your attitude on like the Google Professional Data Engineer certification on Google Cloud Platform?
Yeah. I mean, like I think it's always like certification is always interesting because it's like to me it's like an MBA where it's like it's super useful once you've like gotten experience, because you can start applying all of these concepts that you've been kind of working on. Again, like I had all these concepts there for like a year where I was like kind of touching ETL, but I didn't know it was an ETL. I was doing some data warehousing. And you just need something that like pieces it all together. And I think that's often where certifications come in. I think it'd be nice to see a more generalized. I mean, I think Udacity has their generalized certification, but just something more generalized, right? Like you do the IBM, you do the Google, it's going to be obviously leaning towards their product stack. And that's not necessarily teaching you full data engineering, it's teaching you data engineering on their stack, which is not necessarily wrong, but it's it's just one version of like so many at this point. So I think there's definitely value in it, but I also think it's like, at what point is it valuable to someone to actually get a job? And that's the harder thing. It's like, okay, does this help you get a job? Because I think that's why most people get it. I think it makes sense afterwards, after you get the job for sure. But it's like, okay, before, is someone going to look at that and be like, yeah, this person can be a data engineer?
Yeah, it is crazy, especially with the GCP data engineering cert being the highest paid IT cert right now.
Yeah,
that's bananas.
Yeah, it's crazy. It's a big shift. Yeah, my attitude is like if I'm looking to hire a junior data engineer, an intern, and they've got one of those certs, that shows a lot of initiative. I'm not going to assume that they actually know data engineering.
But the certs are hard.
But they're hard, right? It's like, okay, so someone while they were in school or while they had another job took the time to like study and actually pass the certification, spent the money. Yeah. I'll give serious thought to hiring them.
Yeah.
It's a good question here, actually. How do you separate the signal from the noise in good and bad certifications? Are there any red flags or positive signs of good certs that you guys find consistently? What's up, Custom? I see him on Harpreet's office hours once in a while. He's a smart guy. What do you guys think about this question, though?
I kind of feel like the certs from the heavy hitter data companies, by which I mean Google and Amazon, are probably your best options. The Snowflake certs I think are really good. I think some of the more obscure certs for various data products might not be quite as valuable if it's just like on one. So with GCP or AWS, you're getting certification for a whole ecosystem, basically. With Snowflake, again, it's becoming more of an ecosystem. It's a really significant product. If it's just some, I won't name names here, but if it's just like one, data tool that does some small thing, it might not be quite as valuable.
Yeah, I think the other thing that I've seen in terms of like certs was I saw one that in particular looked like it was more like mostly software engineering for like 80% of it, and then like one little tiny bit on like data engineering kind of concepts. That was like really light. And so I think making sure that you see a good focus on like, yes, you need basic code, you need basic SQL. In a weird way, it's almost nice to just assume you should have those, and then the cert should just be more data engineering focused after that. So I think that's also nice if it's like you should already know Python and SQL or coding and something like that, and then we're going to teach you this layer on top, right? That's totally focused on data. Which I think things like the Google cert expect you. Like they even say like, we assume you've already been doing data modeling for a little bit, or at least coding for a bit, or SQL for a bit before you jump into this. And I think that's kind of important, because otherwise you basically have to do a full like tech pre-course and then kind of jump into a lot of this other stuff. So I think that shows like some maturity in a cert. If they like, look, we know you need X and Y before you can get started. We're not going to reteach you that. We just assume you've done that somewhere else. So
I would look at the experience of the instructor too, right? That's a big one.
Yeah.
So I've seen some data engineering certs where I'm like, this guy obviously hasn't done data engineering at all. So, but it's a hot thing. There's going to be, so I would expect there's going to be more certs, is my point too. But you got to beware, right? There's a lot of certs in data science. I think most of them are just garbage because people aren't doing data science, right? I would say look at your instructor, look at their background, look at what they contributed to the the community, and what are they doing, who are they partnered with, that kind of thing. But you're going to see a lot more data engineering courses and certs coming out. I would say do your homework for sure, because I know for a fact I've seen a lot of these courses coming out for data engineering. And I know a lot of these people aren't doing data engineering. I'm not going to name names, but I'm just saying, there's, I just don't want people spending money and wasting their time, right? On getting false hope and getting a cert that's not going to have much value in the marketplace. So your time's very limited and your money's limited. So spend it wisely. So my litmus test is like, look at the certs that are paying a lot of money. Look at rankings, for example, that at least signals something out there. So, and look how many other people have the certs. If there's just like 2 people on the planet, then it's kind of tells you what you need to know. So, I mean, we fought around the idea of having an academy and stuff, and maybe we will, but it's kind of like, I don't know. It's a lot of work, and I'm not sure what the benefit of it is in some ways. It would need to have, I think a lot of backing and a lot of thought to make it really good. Yeah. Because I think it's easy to spew out like a pretty low quality course. It's a lot harder to put out something that's, really, really good. Yeah. So, yeah, it's a good question. And
yeah. And I feel like what we need in a really good data engineering certification is just, you don't have to understand the details of how to configure Kafka or, Kafka brokers. You do need to understand roughly how streaming systems work, what the limitations are, when you should use a streaming system, when you should use something else. How do columnar data warehouses work, columnar databases? You'd be shocked at how often people don't know that when they're adopting Snowflake and what kinds of mistakes we see, what the update strategies are, various streaming architectures into databases. And I actually feel like the Google cert does a fairly good job of this, but like you were saying, Ben, it's still very focused on Google products. And so I think the world needs a more general cert that gets that kind of general data engineering knowledge that people aren't necessarily picking up just in the course of their jobs.
Yeah. Or a body of knowledge, like a book. Data engineering. Yes. Sure. One last question here from Mike Schultz. What's up, man? If you have the resources to do whatever training necessary, is it ideal to study software engineering to get into data engineering? Is that the best route? Or essentially, who makes the best candidate that you're transitioned into data engineering?
Yeah, I mean, I guess I can kind of go first. Who goes first? No, I think like it's like it's you have like the same thing I think with front end engineering with data that you have with data engineering, which is like you can learn software engineering in school, but you may never touch the concept of front end engineering, right? And it's the same thing with data engineering. You could learn, all of your software engineering concepts and cover 30 to 50% of what a data engineer does. It gives you the good foundation, but it's not going to give you the theory and concepts that you need to now apply that foundation to. Whereas again, if you come from a data analyst side, you're going to have more of the applicability and what you're actually doing with this data, but you're not necessarily going to have the tools like programming and things like that to actually make it happen. So I think in both sides, you're always going to have that missing 30 to 50% that you now need to add on, whether that be more programming and technical or that be more theory and application. So I don't necessarily think one side has a better shot. I think it's just how technical were you to start with as an analyst? If you're a very technical analyst anyways, you liked writing even VBA scripts or something like that, just to at least get you familiar with programming, then you kind of can make that transition easily. And then same thing with software engineers, well, were you kind of already doing some like you said earlier, Matt, thinking about big data sets kind of work anyways, then that transition is very, very natural as well. Otherwise, if you're doing microservice work, it's going to be weird. It's going to be oh, wait, now I'm thinking about billions of rows. I'm not just thinking about this one event transaction that's occurring. How does that change my whole paradigm on what I'm trying to actually build? You're applying it very differently. And then same thing with the other way below. It's okay, well, I have the knowledge of what we're doing. I have good data sense. I understand duplicate data. I understand kind of some general transformation concepts. But how do I actually do that? From a technical side, how do I program that into, code? And so I think both sides kind of have a missing component on there.
Mm-hmm. Interesting.
Yeah, and it's hard. I feel like there is kind of a training gap still. And I don't know how to fill that just yet. What I look for, frankly, is just, a lot of experience with data combined with some software engineering. And people like to complain about SQL. I actually think that knowing SQL really well is a great prerequisite for data engineering because it does teach people that set theoretic thinking about data, even if they're ultimately going to write Spark or some other language. I know that they understand basic concepts like keys and joins and uniqueness and those kinds of things that actually are really, really critical. But yeah, it feels like there's another opportunity here at the same time. Obviously, the code school and training market is not doing real hot at the moment for various reasons.
Yeah, it's a good question. I would say just start with where you are, but pick up the things like data lifecycle management and stuff, I think are pretty key, and just where,
Yes.
different practices fit. But I always think like software engineers sort of like the wrestlers of like MMA, where if you have a good wrestling background, like MMA, I think is a lot, the fighting, mixed martial arts.
Yeah.
It's easier to get into for a lot of reasons, because you just see this historically with wrestlers getting into MMA. They can kind of control where things go. I think software engineering is very similar in that you at least understand how things should flow, right? There's a certain life cycle management and continuity to it. So I think that gives you a big advantage. Plus you can code. Like that's actually, I think, a good skill to have. But yeah, there's not really a right or wrong answer to this question. I would just say start with where you are and, fill in the gaps. Just understand it's going to be work regardless. So cool. I think we're coming up in time, but it's always fun chatting. We gotta have you on the show more often.
We really should.
Yeah. For people who want to find out more about you, Ben, how would they do that?
Yeah, I mean, if you want to learn more about me, obviously you can look up Seattle Data Guy. I think I show up pretty quick, whether it's on YouTube or Twitter or LinkedIn. That's where I'm at. Always trying to put out like
Medium as well, right?
Oh yes, and Medium. So I'm trying to put out a ton of content around the whole data engineering space in general, as well as just data and good career advice, hopefully. So if that's what you guys are looking for, please check it out. If comment if you think that you need something else that's not being covered.
Awesome. Yeah. Cool, man. Well, have a good day. And thanks to the audience. I think this is a really good discussion. There's a lot of questions in queue here. Sorry we couldn't get to everybody, but next time. Also, if you haven't, subscribe to our YouTube, Ternary Data. Subscribe to our newsletter as well. Exclusive content comes out every week. Got a lot of shout outs recently for some stuff we've been doing. People seem to like the content. So if you like good content, subscribe. It doesn't show up anywhere else either. We might have archives of their newsletter, but stay tuned on that. Otherwise, happy Monday. Enjoy your week. See ya.
See you guys.
Take care.